Nope. Good. Okay. Awesome. Hello, everyone. So Alyssa saved me the intro of myself, but I've been doing this for a long time. So it's been an interesting journey for me over the last 15, almost 20 years. It's watching us go from like Windrunner. How many people know Windrunner? Yeah, look at that. Awesome. And through all the different changes that have happened. One of the things that's always been interesting to me is, we have all these different tools. We have functional scripts and performance testing scripts, and they were always different, and there are reasons for that. We're going to go through some of that tonight, but what I've always considered kind of an interesting challenge to try to embrace is doing everything the same way throughout the spectrum of testing. And so that's kind of the personal challenge that I've had for a few years, and in some ways this is kind of a show and tell of what I've been doing with it. Quick little agenda of what we're going to go through tonight. How many people have done load testing? Okay, so we got a few load testers, but for some of you, this is probably not something that you do regularly or have done before. So we'll do a refresher. Let's kind of go through some of the basic concepts, how load testing is done, sort of what are some of the sort of parameters of that. And then we'll go through a little bit of the distinction between protocol-based testing and browser-based tests. And that's really going to get us into the theme of what we're going to discuss tonight. Taurus is a tool that we can use to stitch some of this together, and that's one of the things that we'll focus on. I'll give you an intro to Taurus, which has a lot of capabilities. We're going to have kind of a specific focus tonight, but Taurus is actually very cool. And then we're going to talk about leveraging the cloud, now that it's back up, for scaling this out. And then we'll talk about putting this all together in Jenkins. So really what we're after is how to do a real load test that looks like real users doing real stuff to your app. And so let's start with a load testing refresher. As we all know, sort of kind of the basic landscape of what we're dealing with is we have some user who's going to connect to your app, right? It's going to be a browser, a mobile device, whatever it might be, and it's going to send a request to some backend, right? And then that backend is going to process the request, execute some code, and return some response. Basic stuff. With load testing, for many, many years, what we basically did was we took that user activity and we turned it into a script. And that script became what we called a virtual user. There were a lot of reasons why we did it this way, but mainly we wanted to do it this way so that we could scale. So we could take this script with limited resources, with limited hardware, and run 10 or 100 or 1,000 or 100,000, or if you're Walmart in September, you're doing 1 million virtual user tests because you're getting ready for the retail season. And to scale that large, we had to basically do it at a protocol level, right? We would use tools like JMeter, and really we would use LoadRunner. Now we use JMeter. But there are a lot of different tools. There's LoadRunner, Silk Performer, JMeter, Gatling. There are a lot of different tools out there. But what they have in common is they have this protocol-based approach. It's essentially going to skip the front end entirely and send a request to the server that's the same request that a user would send, but there's no browser involved. And a while back, this was okay because we didn't do a lot of front-end development, right? It was HTML, maybe some jQuery. Which browser are you using, if people remember those days. But these days, the front end is just as important as the back end and actually has a ton of logic in it. So the problem with not using real browsers is that we don't get, we have some challenges, right? So we have session-based dynamic values. We have things that are used to do things like prevent cross-site request forging, these tokens that are issued, or maybe there's a session variable that's used to kind of mimic state or manage state beyond just a cookie. And if any of you, the folks who have done load testing, this is actually the hardest thing to do. When you're creating a load test and you're trying to duplicate user interaction with a site, you find that all of these values are unique and that requests break if you try to reuse some token. And I've spent hours of hair-pulling time trying to find these things because you have to find them and then capture that value and then replay it every time it's needed in the test. So that's one challenge. Another is that if you're just using protocol, if you're just doing a protocol-based test, if you're just sending an HTTP request with whatever the payload is, you're never executing any JavaScript. You're never doing anything on the front end, right? And this has always been a challenge with the old style of load testing. So we don't get actual page loads or JavaScript execution. And basically what it amounts to is that we're not actually seeing what the user sees. So we run this end user, with a so-called end user load test that's sending lots and lots of traffic to the back end. And that's fine, because the back end, that's kind of where we've been focusing. We look at what the server stack is doing, what the application server, the database, and so forth are doing, and we tune and troubleshoot that. But now, over the last 5 years, so much logic and code is being put into the front end. And if we keep doing load testing like this, we're really only testing like half the app, right? So how do we do this? Well, we want to take those same users. We want to be able to scale lots and lots and lots of users and use real browsers and actually get real users and real page loads and JavaScript execution. So what's the tool that we should use for this? Selenium, right? So Selenium can actually do the end user interactions that we want, and it can replay them automatically. We can incorporate this into a CI/CD kind of pipeline and actually have this automated. But the question becomes, can we run this kind of test at scale? If we're running 10 users, that's pretty easy. We can set up a test and we can just script a replay of that test and kind of loop through it or something. But that's not really a load test. That's a few users hitting the site. We can do that manually. So we want to be able to do this real browser sessions at the scale that we need and be able to bring these results together and be able to troubleshoot where our performance bottlenecks are, find those constraints and fix those constraints. The answer is that we can do this, and we're going to use Taurus to do it. Now, Taurus is, it's basically a YAML-based test runner for CI and CD. It has its roots in JMeter, and if you were to use Taurus kind of just as a plain sort of just call it the kind of core or basic use of Taurus, it's actually going to execute JMeter behind the scenes. But it can also run Selenium tests. It can also run Gatling. It can run a bunch of other different tools. So Taurus becomes this kind of really interesting description or declarative description of what our test should do, depending on the test runner that we have. And in this case, we're going to be talking about Selenium. When it comes to actually running a load test, there are three major things that you want to do. The first one is actually creating the test script. This represents the user logic. This is interacting with the site, filling out forms, clicking on links, clicking on buttons, whatever it might be. And for us, since we're doing it with Selenium, we'll just use the Selenium script there. And this is actually a little snapshot of the script that I'm going to use. It's really, really simple. But it's a Python script, just goes to a page, fills out a form, and checks to make sure that the right result shows up. The next thing we have to do is generate the desired load. We want some mechanism by which we can say, I need to hit 1,000 concurrent users, and I need to do that for 10 minutes or 20 minutes or whatever the case may be. There are different kinds of load tests, right? There's a traditional load test, which is where you want to say, I have my expected usage, and I want to reflect that load profile and make sure my app can stand up. That's kind of a traditional load test. But you also have a stress test, which is I'm going to throw as much traffic at this thing until it breaks. And then I want to see where it breaks. And that's kind of a purposeful thing. But then there's also an endurance test or a soak test, which is to run a little bit of load for a really long time and look for things like memory leaks and other problems that happen. But we need some mechanism to control that load, and that's where Taurus comes in. Taurus is going to give us a YAML-based approach to describe what this test should do. We could script it. We could we could roll our own here, but Taurus actually provides a nice simple framework for us to use to execute the load test. Now, finally, with a load test, of course, the main thing we're after is finding the constraints and the bottlenecks. We want to know where the application is slow, and then fix it, tune it, increase the performance, make sure that it passes muster, and that our users are happy. And we need to analyze the test results. Taurus actually does collect results, but because we're going to do this at scale, rather than taking each test runner, let's say we have 100 machines or 1,000 machines that are all going to hit our site with a browser, each of them is going to have a CSV file with the results in it, or an XML file. That's your choice. Rather than kind of try to create some mechanism to sort of take in all that data and aggregate it and so forth, I just decided to use New Relic. How many people here know New Relic, aside from Stephanie? Yeah, so I mean, you could use any APM solution. You could use Dynatrace or what's another one? App Dynamics. How could I forget? Yeah, Cisco App Dynamics, exactly. Any will do, but the point is that they're going to collect those metrics for us and give us a centralized place to look at really good graphs and really understand whether or not we need to tune anything or where the performance bottlenecks are. So that's the landscape of what I'm going to show. We're going to start with Selenium, put Taurus around it so that it can execute a certain way, and then bring all those results into New Relic. Now, of course, we have this other challenge, which is how do we automate the creation and execution of these actual tests? In the old days, we would do things like we would have a small test lab, and we would have something that was nowhere near what our production environment was like. And people would do I used to work with LoadRunner, and people do like the weirdest calculations to take, say 100 users running against one server, and then just do some kind of extrapolation and say, well, if the bottleneck is, let's say, network I/O for 100 users in one server, well, then it's the same for 10,000 users and 100 servers. And it never works like that. Like, complicated distributed systems fail in weird ways when you start to ramp up the load. So we really actually want to be able to execute this in the most realistic context possible. The whole idea is to get as close to the real user as we can, so that the variables are reduced and we're not chasing bottlenecks and discovering things in production. So how do we automate the creation and execution of all these real browser sessions? What I'm going to do is use Fugue for that, and that's where I work right now. But it's an amazing technology for creating AWS resources, right? So provisioning out the things that you need in the cloud, which as of 2.5 hours ago now works again. But what I've done is I've taken an AMI, an Amazon Machine Image, and I've preloaded it with Taurus, with the execution engine. When that machine comes up, I'm going to put it in an ASG. This is kind of a little bit deceptive because that ASG actually could have any number of servers behind it. And in this case, it's going to be like, I'll just use like 10 or 20. I do have a budget, but you could easily do 100 or 1,000 or whatever. And what we're doing is basically leveraging a launch config to spin up those machines for us. How many people here work with AWS on some? Okay, so you guys know what I'm talking about. And so then we could say, we want to run 10, we want to run 100, we want to run 1,000, whatever it might be. This is our test sort of, our load generation farm, if you will. And it's going to spin up on demand. The other side of this is the production lab issue, right? Where we used to do this kind of, like I said, we had like a smaller test lab than our real production lab, and we had to try to do the math. We don't have to do that anymore since we can just reproduce our production environments in the cloud. So I'm going to use Fugue for that as well, which is going to spin up the application under test itself. Now, I actually chose this really simple app. I just put this thing together, and I got to tell you, it's so fast that I don't know if we're actually going to find real bottlenecks. I tried to constrain it by adding a bunch of text and some background images and things, but we'll see how it goes. It's super fast. But anyway, we're going to spin up the test orchestration, the test runners themselves, and we'll also spin up the production environment clone. And we can do that all automatically in Jenkins. So we're going to go stage by stage here. I'll show you how Taurus works first, and then we'll run a couple of local tests just to see it in action. And then we'll go switch to the cloud and do that manually, and then finally we'll bring it all together in Jenkins. Make sense? Cool. All right, demo time. I think for the demo, I'm probably going to have to lose the mic. Can you guys hear me? Good? All right.
What?
Huh? Yeah, okay. All right, very good. So, cheers. All right, so let's get started. Okay, so first let's look at our test. I have a little test here that I created Actually using Selenium Builder, if you guys, I'm sure all of you know Selenium Builder, because I'm lazy and it's easy. So I just created a simple test here. What it does, I have it running locally, I think. Let's take a look. It's a really simple Flask app that I put together with a Bootstrap front end. That's it, right? So the test case, just by way of having something to demonstrate against, essentially hits this button and then fills out this form, and it's got a bunch of dummy data in there, whatever, and then clicks send, and then checks for this message to make sure that we have the right page. That's it. That's what the test does. This is the test itself. And you can see I'm just using a bunch of IDs to locate the different elements and then doing the assertion here on that message, right? Pretty simple. So Taurus is the way that we're going to actually drive this load. Now, I'll shift gears a little bit just for a minute and show you a more full-blown Taurus test. So Taurus has a bunch of different sections in its YAML that can control load test. This is an example of a JMeter test, and this is kind of the protocol-based approach that I was talking about before. And if you're just running on your local machine, or you just have limited resources, this is a great way to get that scale. Again, it's only at the back end, so you're not getting that front end experience. But you can see it's pretty straightforward. The first section for execution, concurrency is the number of threads, the number of sessions that are going to be run. The hold for is the duration. Ramp up is a traditional load testing sort of strategy where you don't want to necessarily hit the app all at once with every request. You actually want to build that traffic slowly. So the ramp up period is essentially dividing that by the total duration, and you'll get how many users you are adding per second or whatever. So those are some of the parameters for a load test. And then the scenarios are what the script should actually do. And in this case, we're doing a lot more than just what's in that Selenium script. We're actually getting each page. We're getting the home page, getting the contact page, and then we come to things like having to extract a value. If you remember on the slide, we have these tokens and these things that are sort of ephemeral, unique IDs that if you're using a browser, you never see. But when you're trying to replay a load test at the protocol level, you got to go search for this. You got to use a regular expression to grab that value and then replay it everywhere it's needed. This test works. It's totally fine, but it's just that back-end test. Now, with Taurus, the Selenium sort of wrapper for Taurus is actually much easier. It's just going to be the execution section. We're going to tell it to use Selenium as an executor, how long we want that test to run for. With Selenium, we have a test runner involved, some kind of framework that we're using, right? So JUnit or something like that. I'm using Nose because I'm using Python. Taurus has some subset of test frameworks that it supports. And for the scenario, we'll just point out our test. So if I run this right now, I'll just run Taurus is BZT, and in fact, to install it, you just use pip. It's a Python app itself, so pip install BZT will get you where you need to get. Once it's installed, you can simply run that test. Now here's the cool thing. Taurus has a cool console that shows the stats. And you can see the test is running behind the scenes. And it's going to loop through it for 2 minutes because that's what I told it to do. So that's kind of the first step in automation. We just want to be able to run through that script with a real browser and capture some timings, right? So very straightforward. You can see it's starting to report back 1 user, hits per second, whether or not there are any errors, and average response time, and so forth. All that data is saved as CSV or XML if you want to use that. But that's really simple, right? It's 1 user. It's not that interesting. So let me kill that one. And you can see I already have this ready to go. These are already here commented out. One of the cool things you can do is simply repeat the executors. It's kind of a hack, but I know the guy who wrote Taurus, and I asked him, how do I run parallel sessions? He's like, just copy and paste it. So it works. He's Russian. So do that and watch what happens. So you can see all the browsers load in the same spot, but you can see them in my dock there running. So now I have 4 users. So depending on the horsepower of your system, you know, you can have as many as that system can handle. If you're using a very large, powerful machine, big CPU, lots of RAM, I got 16 gigs of RAM, you can get a bunch of executors. So that's sort of the next step up, the next sort of step in the right direction. And you can see on the right, Taurus is telling us what the local resource usage is like. We can see memory and CPU. CPU is the one to keep an eye out for. When you're running a load test, just a tip, if you start maxing out the CPU, then all the timing gets skewed. You end up with what's called clock drift. And so you get unreliable timings, which defeats the whole purpose. And you even get like negative timings and stuff. It's weird. So CPU is the more important thing to keep an eye on. But it's just going to do that, right? So that's Taurus running Selenium. It's pretty straightforward. However, that's 4 users, right? That's not that interesting yet. So we want to be able to take this and run it in the cloud. And that's where Fugue comes in. What we're going to do is, as I said, we have the application under test itself. We want to be able to duplicate that production environment. But then we have the test runners. So we need to stand up 2 different workloads. And Fugue is a declarative way to do this. Your tool of choice. This is not meant to be a vendor pitch. We love Fugue, of course, but obviously there are a lot of different solutions out there that can stand up AWS stuff. This is the app under test. This is basically a declarative file showing the different things that I'm going to stand up. I ended up just using one. Again, I'm really trying to force this thing to perform poorly. So I'm just using one server here. But the idea is that, you know, if your workload is an auto-scaling group with a launch config, some IAM roles and so forth, a load balancer, you can use some declarative syntax with Fugue or another tool to stand up your application, and it can look exactly like production. So you don't have to do any weird math. You can actually stand up a production clone against which you're going to basically send that load. The other part of this is the load generator itself, which in this case is very similar. We're going to put it on a network, and then I'm going to launch 10. Why don't we change that to 20 for this? So I'm going to launch 20 load generators. Now the thing about AWS when you're launching a system like this is you can use, whenever you boot up an EC2 instance, you can send user data, right? So that's some instructions to bootstrap the system, whatever you need to do. And so I just leveraged that to do a few things. Basically what I'm going to do is check to make sure the first block here, the first section in my user data script, it's just a shell script, is waiting to basically checking the load balancer in my production app until the machines that are behind it report that they're in service, which is basically saying that the web server's up, the machine's healthy, the app is ready to receive requests. We got to wait for that first, otherwise we're just firing into the void, right? Then I'm going to grab the public address of that load balancer because my Taurus script needs to know what the host name is going to be. And then the rest of this is just pulling down some my test repo and changing some permissions to run the test. So I'm using user data to spin up all of these load generation machines, also using it to stand up the app itself. So let's go ahead and set these things up. And this takes a couple of minutes to fully come together. So why don't I do this first? Oops. And then we can maybe have some questions or whatever. For Fugue, when you have what we call a composition that describes what your environment should look like, we say Fugue run, and we will run that app. And I'll just call this demo app. And then we want to run the load generators, which is a secondary one, which takes all that code that we just wrote, turns it into a managed process that's then going to provision all those AWS resources automatically. The second one will be the load generator, and I'll just call that demo load. All right, so that's going to stand up. Now, once all of that comes up, we'll start to see those machines and so forth load up in our AWS account, and that'll take a minute or two. And then when the load actually runs, we'll see some activity in New Relic. looks like there's some, all right, very good. We'll say ending now, 30 minutes. Okay, so some of that just ended, and we'll have some new stuff coming in. All right, so any questions? Does that all make sense? Everybody with me? Neil.
So do these executors on all the Selenium dependency, like baked into the image and all that?
Yeah, exactly. So I sort of shortcutted this by kind of having the AMI baked and ready to go. If you were to do it in a more real world, you would use Packer or something, okay, right, to sort of build the AMI as part of the continuous delivery process. It takes like 10 or 20 minutes to do that. So I just sort of have it all stuffed in there. But yeah, the test runners have everything that they need to execute the test.
Has Taurus has any runners to do with Cucumber or any of the other type of BDD testing?
No. Yeah. I mean, this is very much kind of MVP, right? It's a work in progress as far as that goes. It was really sourced to be the kind of the sort of missing DSL for JMeter, but once Andre, who's the chief contributor, sort of saw this potential and just started adding a bunch of stuff. So it's a pretty active project.
Can you talk a little bit about the benefits of this type of approach versus like a hybrid approach where you're putting the server under load protocol type tests and a small number of tests? You're coming to the conclusion, which is right. No, that's a great question. I mean, I'm sorry. Yeah, absolutely. So the question is, the difference or the benefits of doing this versus a hybrid approach where you're putting the application under load and then sampling the front end, and that's probably the best way to do it, right? And so, for me, this journey was about exploring. I sort of had this idea that, well, we have the cloud. Why can't we just spin up 100,000 machines? And if you left that running for 20 minutes, you'd have a gigantic bill, right? So there's efficiencies and there's trade-offs, and ultimately, and this is we'll show this with Taurus, but ultimately, Taurus can do them both, right? So you can create a test for the front end and a test for really stressing the app and bring them together. And that's one of the reasons I use New Relic, is because New Relic can show me the browser performance while the app's under load. The browser performance is going to be page load times, how much time is spent on the network, how much time is spent processing the DOM. How many people use New Relic? Ah, wow, a couple, not that many. App Dynamics? A lot of different APM solutions can do it. But the idea is that when we're talking about the front end, those are the things we want to think about. We want to think about, where in the DOM, what resources, what images, what kind of processing on the front end is holding things up for the end user. And for that, you really only need a decent sample, right? Not everybody needs to be from the front end. If you had 10,000 users hitting the back end, and then you had, say, you want a good sample, and you probably want to mix up your browsers. You probably want, lots of Sauce Labs combinations. And then you get a good sense of what the end user perspective is while the app's under load. And that's what it all ends up coming down to. So it takes some time for all this to come together, but it is working. It is working hard on the back end for us here. Let's see where we're at.
Just one more question.
Yeah.
Could you go through like a sample flow of when you found something wrong and how, like, what steps were taken to remediate it? So let's say you ran this, something came back, and you investigated and then fixed. What type of problems are generally diagnosed here?
Yeah. The challenge I have with that, and this is I was sort of joking about earlier, is this application is not very real. so I can speak in theoreticals. So I mean, the whole point of using something like New Relic or an APM solution that's going to inspect the code execution path is exactly that, right? You're going to go and look at the data, and generally you're going to look for the spike, right? And so you're going to find where that problem is first at a kind of a high level. Like here you can see most of the time is spent in the application server. And that means that we want to go to the APM section, right? Now the brown is the network time, and there's not that much you can do about that, but you know that it's the network, and therefore that kind of alleviates some of the finger pointing.
And if it is something under your control, like your own interfaces or routers and so forth, you can address that. But typically, the application server is where you can do the most work, right? Either the DOM and the page rendering or the app server are the places where you have control. Because if it's a slow loading JavaScript framework, maybe it needs to be minified. Maybe you weren't, that kind of thing. But if you go into the APM section for New Relic at least, you'll start to get into things like the actual function execution. So you start with what was the slow endpoint. In this case, the home page is at the top of our list. And here you start to break down the different functions that are slow. And again, we're talking about 413 milliseconds. It's not that slow. But the idea of using an APM tool is that we can go right into that specific line of code and maybe refactor it, maybe have better understanding of why it's slow, and maybe it's acceptable. 400 milliseconds is fine, right? But that's generally the troubleshooting path.
And would you bake in these SLAs essentially into the framework and then have it fail? Or would you go and check this out and then, so is that a manual step or would you automate that?
That is a great question. And well, so I'll tell you where I'm actually at right now and haven't figured out yet is how to fail my build.
Yeah, that's my question.
Yeah. I actually haven't figured that out yet, so maybe we can talk about that afterwards. Because right now the load generators are out there and they're executing, right? Taurus has the capability to fail itself, but it doesn't send a signal back to Jenkins, right? You know what I'm saying? Yeah. So because in this case Jenkins is not executing the test, then it's just something out there. Exactly, right. So that's exactly where I find myself right now. And with load testing, it's a lot less black and white, right? With functional testing, if some widget fails or if some 404 or 500 error happens, we can fail the build and go fix that. With load testing, you're much more vague because you may say your SLA is some percentage of responses need to be under some time response time. And maybe that's okay. Maybe for this build, if we're a little bit over half a second, we're all going to decide that that's a manual gate anyway. But yeah, that's exactly, I was working on that this morning and then AWS went down. That's going to be my excuse. So let's see where we're at with the actual load here. All right, so there's my load. And, it takes a couple of minutes to come together, but this is now running. My EC2 servers are all up and running. You can see them there. I have my one little server running there, and then a bunch of load generators, and then the data is coming back into New Relic. So altogether, it's actually pretty straightforward. We're using Taurus as almost kind of like just wiring a few things together to make the rest of this work. The real meat of it is in how we distribute that load in the cloud. And ultimately, what you can then do, I can take this test here, which is the JMeter test. I called it JM load. And then I can take the Selenium load test, and I can actually run them together. And one of the cool things about Taurus is it knows how to merge them. So if I say BZT, and I have my Mac load test. Oh, I have to go back to the test directory. And then also just the JM load. I can just run them like that. And Taurus knows how to do it. It's going to merge those two YAML files together and then execute the test that we just designed. So you can see over there the 4 Selenium tests, but at the very top, there's a JMeter progress bar. And so now we're in what you had asked about, John, right? Now that's what we're doing, right? We're bringing JMeter in to actually drive a lot of load, and then we have a few front-end samplers to make sure that the user experience is good. And ultimately, that's probably the most efficient way to do it. Questions?
Sorry for the consequences of that. This type of stuff seems really useful, but it seems rather expensive. At what point would you execute this in your pipeline? So I don't see something like this being executed on every pull request.
Right.
Your AWS bill will be through the roof, depending on what
Maybe, right? I'm using T2 micros, and with Fugue at least, we can pull it down as soon as it's done.
Yeah.
So I mean, I guess it's all 1 hour, no matter how you do it, right? But you don't end up with that sort of long running lab that's consuming a lot of keeping the meter running while it's basically unused, and also you're not sort of waiting for the lab.
Yeah, yeah.
So there's no, I mean, it's a cost thing. Is essentially what you're right. And I mean, it's a judgment call, right? If you're changing some major piece of code, you should probably performance test it.
Yeah.
If you're adding, changing some copy on the front page, probably not.
To that question, I'm familiar with a couple of shops where they're literally they're running kind of a mix of in-house and cloud-based. In-house is small scale, cloud larger, and they're literally running 80 to 100 tests a day because they are doing it on every single commit. But they're running most of those are super low latency. They can literally be 1, 2, 3, 5 users. But the rinse and repeat hygiene is there, which is that every time somebody touches code, you get performance feedback. And they'll run, like I say, 80 to 100, 85 to 100 tests in a day, and occasionally run really big ones using the cloud. And I don't know how the math is for how often they run the bigger ones, but they are running a test on every build in an automated way using the exact same approach. So it's not like they have 2 separate test suites or 2 separate technologies, or just literally scaling it that way. And that is not expensive.
Yeah, and that's the same with functional testing. You might not execute every single functional test on a
Right.
pull request, but then as you go down later in your pipeline, you're executing more, maybe on different systems as well.
And by the way, it's dependency based. They're literally saying they touch 4 things that affects 6
So a
parts of the
dependency
solution.
tree type of thing.
Totally.
Yeah, yeah, so same.
This is actually happening in real time. What I just did, I think, is saturate my. I saturated my network interface. So where are we here? Yeah. So I have my JMeter test running, which is consuming tons of bandwidth just sending requests and catching responses. And then I have my Selenium test running, and if you see there, Selenium test is not running right now. When it comes up, it's very slow. So, case in point.
To add to the point, basically we run OpenStack locally for running all our Jenkins nodes and our load testing is basically like generating user traffic. But our QA automation and production environments are all running in AWS, and they are replicas of each other in Amazon. But OpenStack, we use OpenStack locally instead of using Amazon for load testing.
So this is interesting. When I hit it with JMeter, I ended up with a lot of request queuing. So it's a much more interesting result than just 4 or 5 machines running from the front end. So I mean that's it. That's basically the landscape. Now to bring it all together in Taurus in Jenkins is fairly straightforward. I used a new pipeline build, and if you're not familiar with that, it's basically a way of scripting your build. And so it's doing everything that we just did, but it's doing it essentially automatically. And so if I commit, then it's going to build, and there's only one branch right now, but this is a multi-branch pipeline. If you have like a Git flow model, if you're doing like feature branches or develop branches, it's really good for not only for load testing your app, but also making sure your infrastructure is going to stand up, right? So you end up pushing your infrastructure through the same process and making sure that whatever changes you've made are going to work, and then you can accept that back into trunk. But basically it's the same idea. And so this is the Jenkins file here, just basically checking which branch it is, and then running the same stuff that we saw where it's running the infrastructure first, and then down here it's going to run the load generators, and then via user data they know what to do. Mobile devices?
Yeah, mobile device.
Yeah, I think the next thing for me to explore is the mobile device lab, or sauce labs. Yeah, absolutely, and that's a much better use case for the scalability and costs and such, right? Because it's unrealistic to get hundreds or thousands of actual devices, and emulators are terrible, right? But AWS has Device Lab, and Sauce has their lab, and Xamarin and various others. And I think the same idea, right, would be to, in this case, maybe Appium would be the right way to go. But get that sample, that sort of front end from the mobile device standpoint while the application was being stressed by JMeter.
But to that point, if you're going to have a ton of executors and all that, that's going to be really tough with a ton of real devices. So,
Yeah.
Here you're using essentially a VM and all of that. So how are you, with real devices, it's going to be very tough to scale that.
Yeah. I think you would just. I think probably the best practice there would be to have kind of the sampling of your actual users. If you're using something like Mixpanel or something that can detect what your users are using. Yeah, exactly, user agents, and then replicate that. The whole idea with load testing is really to shape your load in the right way. So having some understanding of who's coming to your site, when they're coming, what are the traffic patterns throughout the day, what devices are they using, then you can create that front end kind of sampling layer where you have each major device represented, probably via Appium, each major browser and OS combo represented. And there's no reason we can't kick off Sauce job with remote WebDriver and desired capabilities.
Unrelated question, but would you run these tests if the protocol tests fail? Those raw GET requests and all of that, what you were showing earlier, right? The JV.
Yep.
Would you run this load testing via Selenium and Taurus and New Relic if that failed? Because it would for sure fail.
You mean like sort of run a sort of a light test first to make sure that everything's working, and then you could do it that way. I think some of your questions are pointing to just I mean, we need to fail the build fast, right?
Exactly.
Yeah. So right. Yeah.
Very heavyweight. This is great.
Yeah. No, you're totally right. I mean, I think that if I were designing this for the sort of real world, everyday thing, there would be a smoke test section, and there would be maybe most pull requests would be some kind of smoke test, and then larger sort of milestones or whatever would.
Focus is on scaling.
Yeah, absolutely. I mean, it's a really good point, and you have that kind of the smoke test just doesn't work or not, and then do we go to the next stage and do a heavier test, and then there's the manual gate. Is 1 second acceptable? Where usually the SLA is 500 milliseconds or whatever, and those are all good considerations. It really comes down to how you design your build jobs. Yeah. No, it's great. That's great. That's awesome. All right. Other questions? All right. Thank you very much.